There are objects in the universe so immense and so powerful. They stretch the very limits of imagination. A place where gravity bends reality itself, where time slows, and where light itself is trapped forever. This is not a star or a galaxy, but an abyss wrapped in fire. A black hole so massive and powerful, it dwarfs almost anything else we've ever discovered. And its name is... It lies near the border of the constellations Canes Venatici and Coma Berenices. When astronomers first recorded it in 1957, TON 618 appeared to be just another faint blue star. But later spectroscopic studies revealed its true nature. It wasn't a star at all. It was the blazing core of a distant galaxy powered by a black hole of unimaginable scale. TON 618 lies more than 18 billion light-years away in terms of its present-day co-moving distance. The light we detect today has traveled for over 10 billion years. We're seeing it as it existed when the universe was less than a quarter of its current age, a time when galaxies were still forming and the first generations of stars were lighting up the cosmos. At such an immense distance, TON 618 cannot be seen directly. It reveals itself through its extraordinary glow. Because this black hole isn't ordinary. It's one of the most powerful phenomena in the universe. A quasar. Quasars are the blazing hearts of young galaxies, powered by supermassive black holes, consuming enormous amounts of matter. Gas and dust spiral inward at enormous speeds, forming an accretion disk that radiates across the entire electromagnetic spectrum, from radio waves to visible light to powerful X-rays and gamma rays. Friction and collisions within the disk generate temperatures of tens of thousands of degrees. The result is a beacon so bright it outshines entire galaxies, making it visible across billions of light years. Within this maelstrom, magnetic fields twist and reconnect, launching enormous relativistic jets of plasma. These jets erupt from the black hole's poles at nearly the speed of light, stretching for millions of light years, longer than entire galaxies. They carry enough energy to shape their host galaxy itself, blowing away gas, halting star formation, and influencing the evolution of entire galaxies. TON 618 is one of the most luminous quasars ever discovered. Its energy output rivals the combined light of roughly 100 trillion suns. If it were placed at the center of the Milky Way, its brilliance would outshine every star in our galaxy. It would appear dozens of times brighter than the full moon, and our familiar night sky would disappear beneath its glare. At the center of this incredible radiance lies the true giant, a black hole with a mass of about 66 billion suns. TON 618 is more than 16,000 times as massive as Sagittarius A star, the black hole at the center of our own galaxy. Its event horizon, the point beyond which nothing can escape, measures roughly 390 billion kilometers across, large enough to swallow our entire solar system many times over. To stand near it would be to watch the laws of physics unfold in their most extreme form. Around the event horizon, a glowing ring of light would appear, photons trapped in unstable orbits before finally falling inward. Time itself would slow. Seconds near the event horizon would become years for the rest of the universe. A distant observer would see anyone approaching the black hole appear frozen in time, suspended forever at the edge of darkness. At the last stable orbit, the black hole would dominate the entire sky, an endless sphere of darkness surrounded by blazing light. As you moved closer, colors would begin to shift. Light escaping the immense gravity would become gravitationally redshifted, stretched into longer wavelengths. Bright white light would fade into deep crimson, as though the black hole itself were draining color from the universe. Beyond that lies the singularity, a place where density becomes unimaginably extreme, and where our current understanding of physics breaks down completely. Scientists believe supermassive black holes begin as much smaller seeds, perhaps from the remnants of the first stars, or from the collapse of enormous primordial gas clouds. Over billions of years, they grow by consuming gas, swallowing stars, and merging with other black holes. But TON 618 pushes these theories to their limits, reaching 66 billion solar masses so early in cosmic history suggests it either began unusually massive or grew under conditions far more extreme than scientists once imagined. Its very existence challenges our understanding of how black holes evolve. Quasars like TON 618 are not just cosmic monsters. They're also windows into the early universe. Because they shine so brightly, their light travels across billions of years, passing through the gas between galaxies. By studying that light, astronomers can measure the chemistry of the early universe, trace the distribution of matter, and understand how galaxies formed during the universe's first billion years. TON 618 is both destroyer and guide, a force of unimaginable power, and a beacon illuminating the hidden history of the cosmos. When we look at it across billions of years of space and time, we aren't just witnessing one of the largest black holes ever discovered. We're looking into the distant past and catching a glimpse of both the terror and the wonder of our universe.